This video is to review the main points of the oceanography chapter. This is the picture of the features of the oceanic floor. The bottom of the ocean is not nice and flat. It has lots and lots of stuff going on in the bottom of the ocean. You have the start with the continental shelf, which is right here. That is the continental mass. Then it goes into, how the ocean gets deep. It goes into the continental shelf, which is a little bit under the ocean. Then you got the continental slope, and that's a really, really, really deep part of the ocean. Then you got this volcanic islands. This is very similar to Hawaii. And a lot of islands that have started out there, they start out as volcanoes, and that hot spot slowly moves as the land moves and turns into more and more islands. You have an abyss, which is a very deep part of the ocean. The mid-ocean ridge, this is what's happening for plate tectonics. This is where you have land masses going under each other, spreading apart. New land is forming. The abysmal plain is very, very flat area of the ocean where almost nothing lives. There are actually parts of the ocean, nothing lives in certain parts of the ocean. You then also have the guyot, which is the start of a volcano and volcano activities. And as the volcanoes begin to rise, you go into the sea mounts. And that is a seamount that's sticking out of the water just a little bit. Kind of, but not as big as an island. Sticking out, but not as big as an island. And the last little part is the oceanic trench. And the oceanic trench is the deepest part of the ocean. We're not quite sure what's in the oceanic trench. We can't go there and explore because it's so deep. We know there's usually magma right there, and new land is forming, but we're not that sure because they can't explore that part of the ocean. This is a map of the oceans of the world. We have the Arctic Ocean, which is right up here at the top where it's very, very cold. We have the Southern Ocean, which some books talk about, some books don't, but that's in the south. It's kind of touching all the other oceans, so I wouldn't say it's an unimportant ocean, I'm sorry, but it is one that some books talk about, some books don't. The Pacific Ocean wraps around the earth and goes from the edges of Russia, Japan, over to the edges of America, which is California. You then have the Indian Ocean, which is surrounded by Africa and India. You also have and you also have Australia touching the Indian Ocean. You have the Atlantic Ocean, which is actually one of the smallest oceans that goes in between the United States on the East Coast over to Europe. It's a very important ocean because that one was traveled the most by European travelers, but it is one of the smallest oceans. You need to know where all of these oceans are located. We are now talking about the importance of ocean water. You have ocean water. If you see here, let me see if I can open it bigger. If you see here, ocean water or seawater has mostly water and some salt. The salt has chloride, sodium, sulfate, calcium, potassium, magnesium, and other minor elements are in there. That is what salt water is made of. The next section talks about how salty the water is. If you notice, this is a very interesting map to me because it's opposite of a real map. If you notice, the saltiest part of the earth or of the ocean water is right here, and that is the Red Sea or the Dead Sea. If you notice up here, it's not very salty. It's only about 21% saltiness. And the reason why is because you have all the polar ice caps melting, and that is diluting that water. It's making it not as salty. You also have different bands of saltiness. You could look and see why certain areas like here and here might not be quite as salty as other areas. You'll also notice there are ribbons, such as here, that's really, really pretty salty. and then you have some that are not quite as salty. This is all determined by the circulation of the ocean water and what is happening near the oceans to keep the saltiness in there or not. The next important thing is how dense is that water? Remember, salt water is less dense than regular water, and that is why icebergs, which is regular fresh water, float on top of salt water. Two factors of primary importance affecting the density of water is the temperature and how salty it is. So you have the Dead Sea, what is really salty, but it's a little warm. People pretty much sit and float on that all the time in that ocean area because of all the saltiness in there. There are other important influences on global ocean currents. The process of convergence and divergence also plays an important role controlling the density of the oceans. So the oceans are not dense throughout, it's not salty throughout. It's all mixed around how salty and how dense that water is. In addition, the density of the water increases slightly with the increased pressure, and this can become a factor at tremendous pressure of the deep, deep ocean. So that's why when we go to the very bottom of the ocean, there's more pressure not only from the water above you, it's also increasing pressure because the temperature is lower. The next important point to know about oceanography is waves. What is the cause of waves? Look at this big wave. What are the causes of these waves? And what happens to these waves? And what is the point of it? First off, oceans move due to tides. Tides are the rise and the fall of sea levels caused by a combination of effects of gravitational force exerted by the moon and the sun and the rotation of the earth. So because of the moon's gravity pulling, it actually pulls part of our oceans away. And then we get a high tide and a low tide, high tide and a low tide. If you look at this picture, this is a typical picture of what happens in New Brunswick. Here's a picture of high tide where you have water up high, and then as the gravity from the moon pulls it, you then get certain points of the day of low tide. So you have a high tide and low tide. So that is the first important thing you need to know about what causes the oceans to move, the waves of the oceans. The next is that the whole point of the waves of the ocean is that all types of waves are able to transfer energy over a great distance. Over the great distance it travels, depending on the amount of energy the water carries. This is what causes tsunamis. That is a huge amount of energy because of a under ocean earthquake or something that causes all of this huge wave to form. So all waves is a transfer of energy. Waves there are three factors that determine the size of a wave. Let's see if we get that. The first is the speed of the wind. So if you got a really, really windy area, the waves are going to be higher. That's why things like Hawaii, California are good places to surf because they're pretty windy. You got a lot of wind going on there. While on the East Coast, there's not so much wind going, so surfing wouldn't be the greatest. The next is the distance of when the wind blows. On the East Coast, the wind is blowing mostly over land and then going into the water, so it's not really going that far. While out on the west coast of California, you've got the wind coming all the way from Russia. So you have very long distances of wind. And the last factor that has to do with the wind, I'm making a mistake. The last factor that has to determine how big a wave is the last factor that causes waves to be very large is the length of time the wind has to blow. So if the wind is blowing and blowing and blowing all the way from Japan all the way over to Hawaii and California, you got a long time there. Well, if you have wind blowing from the United States across the Atlantic Ocean, which is a little smaller, you don't have a lot of time. So how much time the wind has to blow is how the wave size are determined. The last little piece of information we need to know about oceans are their currents. If you notice that the currents are always moving, and the reason you have currents that are constantly moving in the ocean is to help regulate the temperature of the earth. That's the whole point of it, because if you got cold water up here in Greenland, it's going to slowly come down and go around, go by the equator and warm up and come back up here where it's warm. So the whole point is to trying to do homeostasis and having everything equal. The water is constantly trying to become just as warm as the other water. So that is why we have currents. We also have currents due to a Coriolis effect. Coriolis effect is when the Earth is rotating on its axis, and because it's moving, it's causing all of our water to be moving too. Same thing with wind when we start talking about meteorology, but right now we're talking about water, and that is why it is moving the way that it does. One, it moves because of the Coriolis effect, the rotation on our axis, and two, it happens because it's trying to even out the temperature. Because right here at the equator, it's all nice and warm, and it's slowly going to try to get cooled off. And this cool water comes back up over here. So that is one of the reasons why you always have stuff moving around. And that is what also is causing the energy moving around and the waves to be moving around. Thanks for listening.